Okay, basic probability time. The probability of an event E, and this is your core, your key understanding, is it's the number of ways to do the event E out of the total number of possibilities. So, for instance, what we're going to try to stress on this first card, in fact, some of the first cards as a whole, is the idea of possibilities. So let's pretend we only have these three cards: the Ace of Hearts, the Two of Hearts, the Three of Hearts, the Four of Hearts, the Five of Hearts. There's no other cards as far as we're concerned. What's the probability that if you shut your eyes and the person shuffles the cards, you put your hand out, you pick a card at random, and you get the Three of Hearts? Well, there's one card here labeled the Three of Hearts. There's 5 cards total, so we would say it is 1/5, and that should be the fraction 1/5, but I didn't want to go to the insert menu every time and get out a fraction, so I just wrote it 1/5. Another acceptable way to do it. What about the probability of the Four of Hearts? Well, that would also be 1 out of 5. What about the probability of the Ace of Hearts? Well, only one of those, so 1 out of 5. What about an odd and a heart? Well, I don't really think an ace is an odd. Some people would say, some people think ace is high, like in poker, and some people think ace is low, like it's a 1. It's not universally considered a 1 or an odd number, so we're not going to use the ace here. But the 3 is definitely odd, and the 5 is definitely odd. So there are 2 out of the 5 cards that are, I guess we're going to use a 3. An ace is an odd. So we're going to count an ace as a 1. So there are 3 odds out of the 5 cards. Now, let's do the same thing with a deck of cards. First off, does anybody remember, or do you remember, how many cards are in a deck of cards? There are 52 cards in a deck of cards. So now, I'm not thinking that the total number of possibilities are these 5 cards in the picture. I'm thinking the total number of possibilities are all the cards in a deck. So now there are 52 possibilities. How many of those 52 cards are called the Three of Hearts? 1. So the probability of picking a Three of Hearts from a standard deck of cards is 1 out of 52. What about a Four of Hearts? Likewise, 1 out of 52. What about an ace? Now, not just the Ace of Hearts, any old ace. Well, there's an Ace of Hearts, an Ace of Diamonds, an Ace of Clubs, and an Ace of Spades. So that's 4 different aces in a deck. So that's 4 out of 52. What about the probability of an odd number and a heart? So I think this time I didn't count the ace. We'll see. So there's 3, 5, 7, and 9. Those are all the odd numbered cards that have a heart. So that's 4 out of 52. Yeah, I didn't count the ace this time. So the ace is flexible, it can go either way. Generally, we don't count it. Okay, so now we have another group of 5 cards, and we're going to find the probability of picking, here we go, the King of Clubs, the Ace of Diamonds, pick any picture card, the Jack of Clubs, and the Queen of Hearts. The probability, if we just limit ourselves to the image that you see on the left there, or out of the entire deck of cards. Go ahead, give it a shot. Fill in the entire table. Do it one line at a time. Do like King of Clubs with an image, King of Clubs with a deck. Okay, so probability of picking the King of Clubs out of the image is 1 out of 5. But out of an entire deck is 1 out of 52. What about the Ace of Diamonds? Well, that would be 1 out of 5 from what we see and 1 out of 52 from a deck. What about a picture card? What's the probability of picking a picture card out of this image and then out of a deck? And remember, there are 4 jacks, 4 kings, and 4 queens in the deck. Those are your picture cards. Okay, so in the picture, in this image, there are 3 out of 5 picture cards. Out of a deck, there are 4 jacks, 4 queens, and 4 kings, which are a total of 12 picture cards. What's the probability of picking a jack of clubs? Well, that would be 1 out of 5 in the image and 1 out of 52 in the deck. And what about the queen of hearts? 1 out of 5 in the image, 1 out of 52 in the deck. So one of the types of questions that we frequently ask, or one of the subject matters that we frequently ask questions about in probability is a deck of cards, but another is rolling the dice. Love the Springsteen song, Just Another Roll of the Dice. Great song. So on a roll of a single die, that means just take one. I know there's 6 of them in the picture, and they're sided 1, 2, 3, 4, 5, 6, which is why there's 6 in the picture. And you see a 5 and a 6 here, and in the background, oh, actually I have a 5 up in the background, but 2 in the middle, there's 4 on the right there. So 6 sides, can only get the outcome 1, 2, 3, 4, 5, or 6. What's the probability of a 1, then a 3, then a 7, an even, a prime, or a 2 through 5? Go ahead, give it a shot. Okay, so the probability of a 1, 1 out of 6. Right? There's only one die side that has a 1 on it. What about a 3? That's also 1 out of 6 because there's only one side that has a 1 on it. Remember, the probability of an event E is the number of ways to do E, namely one way. It has to land on the side that has a 3. Out of the total number of possibilities, well, the total number of possibilities is there's 6 sides. So only one side has a 3, and there's 6 sides total. What about the probability of a 7? Well, that would be 0, or 0 out of 6, because yes, there are 6 sides, but none of them have 7 dots on them. Probability of an even number, well, that would be 3 out of 6, because you could get a 2, a 4, or a 6. Okay. What about a prime number? Ooh, what's a prime number? Does anybody remember? Prime number is a number whose only factors are 1 in itself. And for the record, 1 is not a prime number. That is a by definition thing. Okay. So the prime numbers on sides of die are 2, 3, not 4, because that could be 2 times 2. 5, because that can only be 1 times 5, just like 3 can only be 1 times 3, and 2 only 1 times 2. 2 has the unique distinction of being the only even prime number, and 6 is not prime, 2 times 3. So 2, 3, 5, that's 3 out of 6 sides, 3/6. And what's the probability that when you roll the die, you get a score between, and that includes 2 and 5? Well, that would be 4 out of 6, because you could get a 2, a 3, a 4, or a 5. That's 4 ways to get between a 2 and a 5 out of 6 possible ways. Okay. What if I asked you, what's the probability of getting a 5 or a 6? Well, there are 6 die sides altogether. A 1, 2, 3, 4, 5, 6, and 2 of them have a 5 or a 6. So that would be 2/6. Now, another subject matter for probability is when we deal with spinners. So here is a spinner. It has 8 different regions colored as seen. Find the probability of red, then the probability of white, then the probability of green, then the probability of yellow or green, and then the probability of pink. Go ahead. Okay, the probability of red, 1 out of 8. There's 8 sides altogether, and only one of those sides is red, so 1 out of 8. What about the probability of white? Similarly, there's one side that's white out of 8 total. Remember, probability of any event E is the number of ways to do E over the total number of possibilities. What about green? What do we see when we look for green here? Well, there are 2 sides that are green out of 8 total, so green would be 2 out of 8. What about yellow or green? Well, there's 1 yellow and 2 other greens, so that's 3 of those pie wedges, if you will, pizza slices. So that'd be 3 out of 8. And if they're going to do pizza, I have learned of an amazing flavored slice of pizza if you've never had it. Chicken barbecue ranch. Oh, really good. Sounds terrible. Excellent. If you get a chance to try it, give it a shot. And then the probability of pink. Well, there are no pink pie wedges or pizza wedges here. So that probability is, why does it say 1 out of 8? That probability is 0. I have probably copied it and didn't. I would do, because Lord knows I've done it before. All right. So now we have some marbles. 12 total marbles. That means there's 12 ways to do something. There are 4 blue, 5 red, 1 green, and 2 black. Find the probability of blue. Well, that's going to work out to be 4 12s because there are 4 blue marbles out of the 12 marbles total. You figure out probability of red, probability of brown, probability of green or black, and the probability of red or blue. Go ahead. Okay. Probability of red is 5 out of 12. Probability of brown, there are no browns. That's 0. Probability of green or black. Well, look, there's 1 green one and 2 black ones. So that would be 3 out of 12. And red or blue. Well, here's your 5 red ones that we saw before. And the 4 blue ones, that would be 9 out of 12. So let's summarize all we've been through today. Box and whisker plot. The box plot uses the 5-number summary. Minimum, first quartile, median, third quartile, and maximum. And then you make the box in the middle. Don't forget the line down the middle for the median. And then the whiskers left and right to minimum and maximum. A histogram is like a bar graph, but every one of those bars coming up has to touch each other. They always have the frequency on the left and the interval or what you're counting. I don't want to say what we're counting. They have the interval or the measurement on the bottom. Stem and leaf plot must be ordered. Don't forget that. That's the number one way to make mistakes. And the probability of any event E is equal to the number of ways to do E divided by the total number of possibilities.